everybody, this is the last lesson for this week. Calc 1 Day 4, Lesson 12, Section 4. This should be a fairly quick one, but now we're going to look at some trig derivatives. So the derivative of sine is cosine. The derivative of cosine, negative sine. Tangent, secant squared. Cosecant, negative cosecant cotangent. Secant is tangent secant, and cotangent is negative cosecant squared. These are found on page 144 of your book. Yes, I finally have the correct book. The publisher sent me another one since mine was lost in the mail. So let's do some exercises. I'm going to take a look at example 1. This is on page 143. We have y equals x squared sine x. This is a product rule problem. We have one thing times another. So, using the product rule, y prime is x squared times derivative of sine is cosine plus derivative of x squared, 2x. And then we leave sine x alone. And that is really it. Nothing more to do with that problem. All right, example 2. F of x equals secant x over 1 plus tangent x. It's a quotient, so we want to square the bottom. We want to put whatever was on the bottom first. Then we're going to take the derivative of secant, which is secant tangent, minus, we're going to leave this alone. Of course I sneeze. Okay. We're going to leave this alone. And now I have secant x. And then the derivative of 1 plus tangent. The derivative of 1 is 0. And the derivative of tangent is secant squared. All right, now when I multiply this through on the top, I will have secant x plus, secant x tangent x, sorry. That's multiplying this by 1, plus secant x tangent squared x minus secant cubed x. Now we see all these secants in here. So before I put the bottom underneath it, I'm going to simplify it just a little bit more. I'm going to factor a secant x out of that whole thing, and I get tangent x plus tangent squared x minus secant squared x. Tangent squared x minus secant squared x, if you remember from your trig identities, is equal to -1. So the inside now becomes tangent x minus 1. And we still have our secant x on the outside. And can't forget about our 1 plus tangent x squared on the bottom. Okay, that's example 2. We're going to take a look at example 3, and this is on page 145. It says an object at the end of a vertical spring is stretched 4 centimeters beyond its rest position and released at time 0. Figure 5, note the downward direction of the positive. Its position at time t is this. So here is its position function, and we're looking at a function with respect to time. And we have 4 cosine t. So first we need to find the velocity. So finding the velocity, we are going to take the first derivative. So f prime of t. The derivative of cosine is negative sine. So this is negative 4 sine t. And now I need to find the acceleration at the time. So I'm going to take the second derivative, double prime we call it, and that will be negative 4, derivative of sine is cosine. Now, the object oscillates from the lowest point at 4 centimeters to the highest point at negative 4 centimeters. If you can see the graph right here. So it oscillates between the two. And the period of oscillation is 2 pi, the period of cosine. So with the acceleration equal negative 4 cosine t, if we set that equal to 0, we'll find out when it has the greatest magnitude at the high and low points. If I divide by negative 4, I get 0. And I ask myself where cosine is 1 or where cosine is 0. And there we go. Example 4. We are moving right along. Okay, this is interesting. Example 4, we're going to look at the pattern. We have f of x equals cosine x. If I take the first derivative, let's see if we can find a pattern here. F prime of x is negative sine x. Second derivative. Derivative of sine is cosine. Third, derivative of cosine is negative sine, so that'll be negative of a negative. Fourth, we actually write it like this using Roman numerals. Derivative of sine is cosine. Okay, so we see here that it looks like it's going to repeat after that. If I do it again, I'll have negative sine, then I'll have negative cosine, and I'll have sine. So the question is, what is the 27th What is the 27th derivative? Well, if we take 27 and we divide it by 6, we really just want to know what the remainder is. So 26 or 27 divided by 6, divided by 4, because that's our pattern. Divided by 4 goes 6 times. I'm putting my answer where I'm dividing. Now my remainder of 24 is 3. So that means that my third derivative down, my f to the 27th, is going to be sine x. Okay, and that's the last one we're going to do, believe it or not. This is a short section today. So there you go, last lesson of week 1. Congratulations, you have made it. Big smiley face. See you tomorrow.